Welcome to yet another session on business statistics. In this session, we will talk about frequency distribution. Frequency distribution is recognizing data in groups or category. You have a set of data points. Okay, you need to group them and then you will be in a position to understand how the data is presented itself. So under frequency distribution, we can have nominal data and cardinal data. Nominal data, the examples can be type of defects or state, province-wise data or gender-wise data, like that. Under cardinal data, you have cardinal measures or numeric. Okay, you can consider height, weight, age, like that, where the data is homogeneous. So the treatment or doing the frequency distribution for nominal data is straight away counting the number of occurrences of particular type of defect or the data in the state or province, whatever you get. And in cardinal data, you need to identify class interval and then identify the data set within or the data points within the class interval. And once you complete all these things, you will be in a position to draw a frequency diagram, and that's the way you arrive at the frequency distribution. We will take a couple of examples and go through the PowerPoint presentation to understand this in a better way. Frequency distribution is recognizing, understanding data points in a group or category. For both nominal and cardinal data, frequency distribution can be used. Examples of nominal data, you can consider gender-wise data, you can consider country-wise, state-wise data, types of defects, several things like that you can consider. Under cardinal, it is numeric, mostly variables like height, weight, age, etc. Frequency distribution is depicted by way of pictorial diagram using histogram. Let us take an example about frequency distribution, how they get formed. I have considered an example, an airline's defaults. Say in terms of customer satisfaction, about 1 month's data has been assimilated and 100 events considered in that. These are flight delays, refunds, missing baggage and aircrew courtesy. So under these things, when these events are considered, we have got this frequency diagram in which the missing baggage is 42 times, refunds 22 times, flight delays 20 times, and courtesy of the crew that's wanting is about 16 times. So this is the way you depict a frequency distribution for a nominal data. Now let us consider frequency distribution for cardinal data. For cardinal data, you need to arrive at class intervals because it will be a single variable. So we need to have a slightly different method. It is not just by counting. We need to identify the number of data points falling within a class interval. Let us see what's a class interval when you take the example. The steps are: decide the number of class intervals. The rule is 2 to the power k should be greater than or n to arrive at the class interval, and k can be more. The class interval can be more than this. Say for example, if you have 30 data elements, 2 to the power k should be greater than 30. So that is the way you arrive at the class interval. Then build a table with class interval and identify each data point within a class interval by a tally mark. The number of tally marks or the occurrence in a class interval represents the frequency. Class interval is put on x-axis and frequency on y-axis, you get the frequency distribution. Connecting the midpoints of class intervals, you will get a frequency polygon. These are all the steps involved in drawing a frequency distribution for a single variable. Now let us take an example. I have considered the age of employees in an organization. We got about 29 data points in that, and the table gives the age. Let us decide on the class intervals. We saw the rule is 2 to the power k should be greater than or equal to n. Now in our example, the number of employees in the organization is 29, so n is equal to 29. So you start substituting the value of k as 1. So you get 2 to the power of 1 is 2. So you get 2 to the power of 5, which is 32, just greater than 29. So we should have a minimum of 5 class intervals. Now once you decide the class intervals, then you need to identify the size. So to get the size of the class interval, take the lowest age and the highest age, find the difference. So 62 minus 22 is 40, and divide by number of class intervals, and we get 8. Now once we decide on the class intervals and the size of the class, then the next step is we have to find out what are all the class intervals, that is 22 to 30, 31 to 39, 40 to 48, and so on. The midpoints of the class interval will be 26, 35, 44, and so on. The midpoints are required for identifying the frequency polygon. Now for the sake of simplicity, we can modify the above as below from the convenience point of view of the organization. So the class intervals can also be 20 to 29 instead of 20 to 30, 30 to 39, 40 to 49, like that. So accordingly the midpoints will also be like this. So this is the way you have to decide the class intervals and the size of the class and the midpoints. You closely watch, this is an animated slide. It will simply take you through step by step how to identify the age with the class interval and the tally marks and the final tally. Now the age 25 falls in the group of 20 to 29 class interval, and under that you have one tally mark. The age 42 falls in 40 to 49 class interval, that is a tally mark. Like that you keep on doing for all the data elements or the ages. Once you do all these things, you have to sum it up, and that is what is shown in the right hand side. So rectangles, and you can see the numbers are 1, 1, 6, 3, and this is just an example. So you have to complete the exercise for the whole. Now we have learnt how to identify the tally marks against the respective class intervals. Once you do the complete exercise for the class, you will get the class interval, the tally marks, and the frequency. And this is what we need to arrive. And the frequency distribution will be like this, and the midpoints are shown, and you join the midpoints, you will get the frequency polygon. So that is the frequency distribution, and that is the frequency polygon. We have come to the end of the session, and in the next session we will talk about area under bell curve. As a matter of fact, frequency distribution is a precursor to understanding the bell curve. The bell curve is evolute of frequency distribution. That is why I taught what is frequency distribution, why it is necessary, so that you have this background and you can understand better about bell curve. Hope you have enjoyed this session. Have a nice day. Thank you.